Okay, we'll get back to section 4.3, 4.4, and 4.5 here. So I want us to talk about properties of logarithms next. And let's see, I have a handout here, which is laws of exponents and laws of logarithms. Okay, the laws of exponents, we've been there and done that before. Here's these same 8 laws that I had written down earlier in 4.1 and 4.2. Okay, and we've also got corresponding laws of logarithms to know. So let's take a look at those. I got law 1 here, log base a of m times n. That's the same as log base a of m plus log base a of n. So whenever you're multiplying things in a logarithm, like you can split that into 2 logarithms that would be added together. Whenever you're dividing things in a logarithm, you can split that logarithm into 2 logarithms that would be subtracted. Okay. Law 3 says that powers can come out in front of logarithms. So this power of r can come out in front of the logarithm. And I have r times log base a of m. Law 4 says that log base anything of 1 is always 0. It does not matter what the base is. Okay? And maybe just to see why that is here, what if I had y equals log base a of 1? Okay, then I need to show that y is 0. Okay, well, if I use the definition of a logarithm, x equals a to the y, x is 1, equals a to the y. What is the only possible value for y to make this statement true? Y has to be 0, right? We know that anything to the 0 power is 1. So log base anything of 1 is always 0. Okay, that's where law 4 comes from. Law 5 says that log base a of a is 1. So if the base and the input number are the same, you always get 1. Okay, maybe just to see where that's coming from, we got y equals log base a of a. And use the definition of a logarithm, x equals a to the y. So the x value is a, the base is a to the y. Okay, and I have the equation a equals a to the y. What is the only possible value for y to make this statement true? Y has to be 1, right? I know if y is any other number, I'm not going to have a true statement. Okay. So log base a of a is always 1. Laws 6 and 7 kind of go hand in hand by just knowing that the inverse of a logarithm is an exponential. Okay, so if I have f of x equals log base a of x and g of x equals a to the x, those two functions are inverses of each other. Okay, and how do you know if two functions are inverses of each other? You check that through function composition, right? So I need to know that f of g of x gives me just x, and g of f of x also gives me just x. Okay, so if I plug g into f, where I see x, I got log base a of a to the x, and I'm saying that's equal to x. Okay, that's where law 6 is coming from. Law 7, okay. So if I plug in this logarithm into the power for a to the x, I have a to the power log base a of x. That's equal to just x. Okay, and that's where law 7 is coming from. Okay, so again, laws 6 and 7 are just coming from the fact that a logarithm is the inverse of a particular exponential. Law 8 is sometimes called the change of base formula. And so sometimes you'll want to change the base when working with a logarithm to make it a new base. So log base a of m, that's equal to log base b of m divided by log base b of a. You're going to divide by log base b of the old base. Okay, we'll look at some examples where we're going to be changing the base here coming up. And then also there's some important statements on this sheet. It says that if a to the m equals a to the n, then m equals n. Okay, and that's one thing that we've been using quite a bit here. When we're solving an exponential, the strategy is to try to get the same base on both sides. You can't always do that, but so there's more to know. But that's the first thing that I always want to think of whenever I'm solving an exponential equation. The second thing, that's the definition of a logarithm. I would definitely know that. Okay, put a big star by that problem there, that number 2 there, and definitely know that. Okay, that's again the most important part of the exam coming up is to know the definition of a logarithm. If you don't know the definition, that's gonna be a real big problem with doing lots of things on the exam. Okay. Statement number 3 is also the definition of a logarithm, but for when you have the special base e, well, even though the base is e, the definition is still going to be the same as it was here. Okay, and then statement number 4, we have not seen statement number 4, but it says that if you have a logarithmic equation where you have the same base on both sides, so log base a of m equals log base a of n, then you can remove the logarithmic notation and set the inner terms to be equal. So m would be equal to n. Okay, now this is an if and only if. So I could read this beginning to end or end to beginning. So if I have, an equation that had nothing to do with logarithms, m equals n, I can get logarithms involved into that by taking log base a of both sides. Okay, and we'll see some problems where we'll have to do that coming up. Okay, now there's a lot of important stuff on this sheet here. Okay, I would definitely know this sheet come time to the for the quiz and the test. Okay. So why don't we take a look at the notes here. And okay, we covered the exponential and logarithms worksheet. Let's take a look at this example. So I want us to write as a sum or difference of logarithms and give the answers without exponents. Okay, so I got a single logarithm, and I'm going to have us split it all up and use the properties of logarithms that are on this sheet. Okay, so we'll go ahead and do that. Part A, I got log base 5 of x times the square root of x squared plus 1. Well, using law 1, I'm multiplying x by the square root of x squared plus 1. So using law 1, I can split that into 2 logarithms that would be added together. So I'm going to have log base 5 of x plus log base 5 of the square root of x squared plus 1. Okay. Also, I want to give my answer without exponents. So the square root of x, that's the same thing as x to the 1/2 power. Okay, so the square root of x squared plus 1, that'd be the same thing as x squared plus 1 to the 1/2 power. 1/2 is a power, so that can come out of logarithms. Right, that's step 3. I can bring the power out in front. So let's go ahead and bring the power of 1/2. So that's in front of that second logarithm there. And I have log base 5 of x plus 1/2 times log base 5 of x squared plus 1. Now the next thing, can I simplify this further? Like, can I split up this second logarithm into 2 more logarithms? No, I can't. Okay, so you can only split a logarithm whenever you're multiplying or dividing the inner terms. Never ever when you're adding or subtracting the inner terms. Okay, so you get a wrong answer if that happens. Okay, so this here that I got circled, that would be as simplified as we can get it. Okay, let's do part B next. So I got log of the cubed root of 2 minus 5x divided by x squared. There's no base, so when there's no base, it's understood to be base 10. You can write the 10 or not, it doesn't matter. Well, I'm dividing these inner terms, so I'm going to start with law 2, which says that I can split up the logarithm into 2 logarithms where I'd be subtracting those logarithms. Okay, so I'm going to have log of the cubed root of 2 minus 5x minus log of x squared. I also know that powers can come out of logarithms. Okay, so I'm going to give the answer without exponents. The cubed root of 2 minus 5x, that'd be the same thing as 2 minus 5x to the 1/3 power. So let's go ahead and bring out that power of 1/3. You got 1/3 times log of 2 minus 5x minus log of x squared. Well, you can bring the 2 out in front. So minus 2 times log of x. Okay, and this here would be as simplified as we can get things. I cannot bring this logarithm into these 2 terms, right? Because I'm subtracting these 2 terms. And it's only whenever you're multiplying or dividing the inner terms can you split up a logarithm. Okay, so don't make that mistake. Some students do that. So this here would be as simplified as we can get things in part B. Okay, part C, we got the ln of the square root of x cubed divided by x plus 3 to the 5th. Okay, so the ln notation means that I've got log base e. So let's see, to begin this, the way to think of what's inside this logarithm is I got the square root of x cubed divided by x plus 3 to the 5th. That's the same thing as x cubed divided by x plus 3 to the 5th to the 1/2 power. Okay, so let's begin by bringing that power of 1/2 in front of the logarithm. So I have 1/2 times the ln of x cubed divided by x plus 3 to the 5th. And well, I'm dividing these inner terms, so let me use law 2. That says I can split this into 2 logarithms where I'd be subtracting them. 1/2, that's got to stay in front. Okay, so I got 1/2 times the quantity. ln of x cubed divided minus ln of x plus 3 to the 5th. Okay, the next thing is I can bring these powers in front of the logarithms, right? So we have 1/2 times 3 times the ln of x minus 5 times the ln of x plus 3. Okay, and then I can bring in the 1/2 into these 2 terms. So I'm looking at 3/2 times the ln of x minus 5/2 times the ln of x plus 3. And that would be as simplified as I can get it. Okay, so go ahead and circle that result there. Now let's go the other way. Okay, so what if I have a bunch of logarithms that are added or subtracted and I want to combine it all to a single logarithm? All right, so we'll look at maybe 3 examples of where we're doing that. Part A, I got log base A of 7 plus 4 times log base A of 3. Now, before I combine these to a single logarithm, I need to make sure that I don't have anything in front of the logarithm. Okay, so let's see. I have a 4 in front of this logarithm. And what am I going to do with that 4? Well, I can use law 3 to start. And that says I can pull the power, pull the multiplier back so it's the power of the inner part. Okay, so let me do that. I'm going to bring 4 up. So I got log base A of 7 plus log base A of 3 to the 4th. 3 to the 4th, 3 times 3 times 3 times 3 would be 81. Okay, and now I'm looking at log base A of 7 plus log base A of 81. So if I get my single logarithm, I'm going to have to multiply these inner terms. If I take 81 times 7, I'm getting 567. Okay, so go ahead and circle that. That would be my single logarithm. I got log base A of 567. Okay, let's try part B next. So in part B, we got 2/3 times the ln of 8 minus the ln of 3 cubed minus 8. Okay, well, let's begin by using law 3 again. So 2/3, that's in front of the logarithm, right? So that can be pulled up as a power of the inner part there. And I'd have the ln of 8 to the 2/3 power, okay, minus the ln 3 cubed is the same as 3 times 3 times 3, that's 27. So I got the ln of 27 minus 8. 27 minus 8 is 19, so I have the ln of 19 there. And now 8 to the 2/3, using radical notation, that would be the same thing as the cubed root of 8 squared, or I could say the cubed root of 8, whatever that is, squared at the end. So 8 squared is 64, and the cubed root of 64 is 4, because 4 cubed gives me 64. 4 times 4 times 4. Or I can also write it as the cubed root of 8, whatever that is, squared at the end. The cubed root of 8 is 2, right? Because 2 cubed gives me 8. 2 times 2 times 2 is 8. And then if I square that, 2 squared is 4. So I get 4. Okay, either way, I didn't need a calculator here, right? So the ln of 8 to the 2/3, that's equal to ln 4. Okay, so I'm looking at ln 4 minus ln 19, and the single logarithm there would be ln of 4 over 19. Okay, go ahead and circle that. Let's take a look at one more here. So what if I had 3 times log base 6 of x plus log base 6 of 4 plus 1/2 times log base 6 of x minus 1 minus log base 6 of 5. Okay, I know that before I do anything with getting a single logarithm, I need to make sure that there's no multipliers in front of these logarithms. So let's take care of the 3 and the 1/2. We'll pull the 3 up, so it's a power of the inner part there. And then we'll pull the 1/2 up, so that's a power of the inner part. X minus 1 to the 1/2 power, that's the same thing as the square root of x minus 1. Okay, so I'm looking at log base 6 of x cubed plus log base 6 of 4 plus log base 6 of the square root of x minus 1 minus log base 6 of 5. And let's go to the answer now. So when I'm adding these logarithms, that would be the same thing as getting a single logarithm where I'd have to multiply the inner parts. So I got log base 6 of 4 times x cubed times the square root of x minus 1. And then we're subtracting log base 6 of 5, so that means I'm going to be dividing this all by 5. Okay, and that'd be the answer. We'll take a look at some more with properties of logarithms next, and in the next video we'll likely finish up these 3 sections here. So, okay, we'll go ahead and stop the video right here.